Sup hacker enthusiasts! Now in this video I'll be demonstrating cross-site request forgery, also known as CSRF or CSRF, and where to find it and some of the mitigations, and also how to chain it with vulnerabilities like account takeovers and cross-site scripting. Now please stay tuned, this video will come up very shortly. Okay, what's up everybody? Now in this very first example, or very first part of the course, I'll be showing you some of the mitigations. So for any cross-site request forgery, what it means is simply craft an especially crafted file or URL that a victim clicks on, and it executes actions in their browsers. So you might have a bank example. So where you have transfer credits from to. So the from might be the email or the account address or the account number, and then it's transferring the money from that account number to another account number. So now if that request or any of that request had no CSRF protection, meaning that it had no CSRF defense recommendations, like if there was no CSRF token or none of that sort of stuff, you can create a specially crafted CSRF proof of concept in Metasploit in Burp Suite. So if you've got a target, just for example, that had no CSRF protection, you can just right click and go engagement tools, generate CSRF proof of concept. And then what happens if that's on a malicious server or something, you can then get the user to click on that link, or it just upload a file to the server, and once they execute that script, it will then transfer money to your own account. So you can transfer all the credits to your own account. So it'll be a modified request that transfers money to your account. So I'm going to go through some of the mitigations first. So let's have a look at cross-site request forgery. I think it goes to that, so let's get out of that. So let's have a look at the overview of what it is. Cross-site request forgery is an attack that forces an end user to execute unwanted actions on a web application in which they're currently authenticated. Awesome. So you do have to be authenticated in this attack, and the file or the URL has to be opened on the same web browser to exploit the authenticated user. And attack specifically targets state chaining requests. Not theft on data, since the attacker has no way to see the response to be forged. So if their account details is in the response, you can't just look at the credentials in the response, because that's when you need some sort of cause a vulnerability, where you might have a vulnerability that's vulnerable. You might have a web application that, like a user ID, or you might have something like you might have your user info page, like say Mail.ru has a user info page, and you view the response. It's got allow access to domains, and it's got an asterisk, and you can inject any origin into the request, and it reflects back in the response, and then you can craft a sort of kind of like a XHR request. Malicious one, I can show you that later on in different tutorials or videos, that will then hijacks the person's account details. And that stands for cross-origin resource sharing, where you're allowed any domain to be referenced or something like that. So same origin policy, it doesn't have same origin policy or nothing like that. First of all, we're just going to focus on CSRF. So I'm going to just do one quick example on Portswigger. So like I said before, Portswigger is a good website to practice these vulnerabilities on. I would highly recommend it. I'm going to also give you tips on how to change it with cross-site scripting, and also how to do account takeovers as well. I'll be towards the end, and towards the end I'll demonstrate the mitigations. So once you create an account with Portswigger, you just simply go sign up and then fill in your details. But I'll just log in because I've already got my account details. Okay, so I'll just log in. And now I will choose to go to Academy. Academy has all the practice labs, free online web security training from the creators of Burp Suite. Really, really good. And they're going to go and talk about cross-site request forgery. Let's click on it. There's 8 labs. We'll try and complete all the 8 labs, but there's also going to be a couple other ones we're going to go over. This one has a better definition. So cross-site request forgery, also known as CSRF or CSRF, is a web security vulnerability that allows an attacker to induce users to perform actions that they do not intend to perform. So it can actually allow a victim to execute an unwanted action on their browser's behalf. It allows an attacker to partially circumvent the same origin policy, which is designed to prevent different websites with interfering with each other. So it's obviously attacks same origin policy. Here's an example. So this URL vulnerable website has the change email functionality. Allows you to change the email to something else. So you might want to be able to change your email because your other one is compromised, or you might be able to change email to a new one you've got, something like that. So this email is a parameter in the URL. Now, if this request, say you type this into the browser, you capture the request with your burp, and it had no CSRF protection. We'll get to how to find if it's. We'll get to finding if it's got CSRF protection in a minute. So if it had no CSRF protection, the attacker will craft a special payload or special file or whatever that the victim clicks on, and it changes the email address to the hacker's one. Simple as that. What is the impact? Well, that very depends on what you do to increase impact. So just simply logging out or logging into allowing the victim to log out or log in through a CSRF attack is not very, it's very low impact. In most bug bounty programs, they don't allow that. By taking over someone's account through changing their email address and password, that could be very high impact, and you can get paid a lot of money. Or even change the cross sites, you can get paid maybe around about $300. Who knows? CSRF that deletes accounts or does very impactful actions will give you lots of money. It all comes down to your imagination. How does CSRF work? A relevant action. There's an action within the application that attackers has a reason to induce. So you might find a delete page or delete account. This might be a privileged action, such as modifying permissions of the other users. So you might go to your PayPal account and you might want to transfer money, or you might want to delete your PayPal account, or you might want to transfer money to your friend's account. But if your friend, say it's got CSRF vulnerabilities, you can craft a payload from an open, and it can transfer it to as many accounts as you want. It could be them, could be others, whatever. That's because you figured out it's got no CSRF protection, so you can transfer any money you want. Cookie-based session handling. Performing the action involves issuing one or more HTTP requests, and the application relies solely on session cookies to identify the user who has made the requests. I'm not going to go through too much in this, but also the CSRF tokens can be found in headers, in the post request, in the get request, and also on the server-side response. But we'll get into how to mitigate all those later. Usually they need to be encrypted and random a lot. They need to be salted and random. Okay, so here's an example. For example, suppose an application contains a function that lets the user change the email address on their account. When a user performs this action, they make a HTTP request like the following. So it's got an email change endpoint. Then it says email user.com blah blah blah. So it's changing the email. Now, if this was CSRF protection, it would have end here, kind of like this. It'd be like this. I'll show you. It's never ever had CSRF protection. So it's have something like that in the post data, and it would have CSRF or have token, or it might have authenticity, and it might equal this long string of an encrypted CSRF token. If it had that, then obviously it would be not vulnerable, but in most cases you can bypass this by removing the token, the variable or the parameter, and do it that way. If it works successful, you bypass it by removing the CSRF token. Sometimes you might want to say, go to another person, go, hey, can I bypass this page? Or another hacker, go, hey, I want to try and bypass this page. Can I have a duplicate copy of your token? Then you might grab their token, and it might only be changed a little bit, and then you copy theirs and paste into yours, and it bypasses it using another token. It's another way. Or you might just want to remove the value, and that might work. I'll provide resources on how to bypass this in I'll go to them in later on. I'll show you how to bypass them. Awesome. Okay, so that's basically one example. That's why I'm going to sip my coffee. Okay, so here is one bit of vulnerable code that meets the conditions of CSRF. Actually, this is the proof of concept, sorry. But this can be generated in Burp if you've got the professional. I think the free one has it too. So it's basically all you need is a document.forms of index0.submit. That will submit your form to the client. So for example, it's got an action, it's a post request, it's changing the user email. The input type is just simply a button. The name is email and the value is this. So the button, it's hidden. And when the victim clicks on the button, it will change the email. This will be submitted to the server, and it will change the email. So then when they go and log in with that email account, it won't. It'll be logged into the attacker can log into using their own email. How to construct CSRFs? Well, there is on this website there is a CSRF generator. So let's open up that and have a look. So Portsfigure you can generate your own CSRF proof of concepts. I show you how to do it all here, but I'm not going to show what to do because I just show you how to do it in Burp anyway, so there's no point. Okay, CSRF vulnerability with no defenses. Let's have a look at an example. So it says select a request anywhere in Burp Suite Professional that you want to test or exploit. From the right click context menu, select engagement, generate CSRF proof of concept. Blah, 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 and we'll just execute it. Let's have a look. So what the lab says is, lab's email change functionality is vulnerable to CSRF. The solver lab crafts some HTML that uses a CSRF attack to change the viewer's email address and upload it to your exploit server. You have an account on the application that you can use to help design your attack. The credentials are Carlos Montana. Let's access the lab and let's exploit it. I said the account login is what was that? Carlos Montana. Don't know how to spell it. Just wait. Carlos Montana. Let's see what happens when I log in. Carlos Montana. Okay, just wait. Let's set so I'll go back here because I need actually that. Just bear with me. I'm just trying to have a look at it said there's something there. Let's go here to Burp. We've got Burp up. So let's go to put that in our Firefox browser because that's where we've got a proxy enabled in, and that's where we're going to use Burp to exploit it. But let's just go back here and have a look at the lab. So obviously we need to change the email. The credentials are Carlos Montana. And we need to. Oh, so this is the authenticated user we need to attack. My bad. So we need to log into this user. And there's obviously a change email functionality we need to attack using CSRF. So Carlos, and it's M-O-N-T-O-Y-A. Perfect. And when we log in, this could just be like logging into a PayPal account or something. You're not the attacker. Well, the attacker logs in, or anyone. And so what we usually do in this sort of situation, we want to add this as our scope. We'll copy that, and we'll just add it in our scope. You can use advanced scope to get more of it, but we just want it basic. And so in a real life application, probably go to advanced scope and just add in the domain name here, so like Yahoo, and go OK, and it will spider through all Yahoo's domains and our subdomains and stuff. We just want simple site scope. That will be our host. And then we want to spider this. So I've got my spider set to 5 is the max link depth, and we want 10 and as the threads, and we want to submit the credentials Carlos Mon what was it? Montoa. It was. Just wait, I need to have a look. Yeah, Montana. So we did that. Now we want to start crawling. Spider. Now also we need to check our proxy settings to make sure it only allows in-target scopes in the intercept client requests, and away we go. We'll start spidering even if there's an account, if it logs into the account. So because we can see this change email functionality, I saw one just before. There's login, and the login has no CSRF protection, but we don't want CSRF login. Go to post. So now what we need to do is we need to spider the host. So we just simply click on links. So we just click on links, might click on that link there, view post. But what we're after is change email. So I'm just going through what you're doing in a real life application. So we click on change email. Obviously it's not there. Let's go back. Whoops. Let's go back. Let's go change email. And we're like, okay, we think change email. Okay, we're not authorized. Okay, we can't do that. Okay, change email. Again, we are unauthorized. Okay. Let's go to. Okay, let's actually capture this request and see if it works. This is what you would go through in your mind as a hacker. Because in the request, it might have change email. It might have to change email. No, it didn't. There should be a post body in there, but it's saying we're unauthorized to access it. Let's have a look at our requests, our spider requests. Nope. Post. Okay, let's try and just go back. Whoops, my bad. Let's go back. Let's see if there is another post in here we can change, because we are logged into Carlos. We can comment, or we can let's try and comment. No, that's not going to work because we want to change email. So the change email is the functionality we actually want. So the session expired. That's why. That's why it said a 403 not authorized. Let's log in again. Carlos Montoya. Let's log in. Okay, so obviously my spidering is logging me out to the right. My spider has the wrong password. Okay, that makes more sense. So what we need to do is when I set my spider to have this password, it's the wrong one. So that's why it was changing my cookie and logging me out. Perfect. Log in. Boom. That should work. Don't save. Alright, so we'll go to change email. I shouldn't say 403 unauthorized now. What we're going to do is change their email to cryptomux@gmail.com because that's my email address, my personal one. And what that'll do is send me an email verification, hopefully. Okay, so let's see. No CSRF protection. It's got no CSRF appended to this post data. It's got no CSRF protection anywhere. So let's generate a proof of concept. Generate, and let's do a normal one. And let's go. Let's go to include auto script, auto run script. Let's do your encoded based regenerate. Let's copy this. Copy this HTML. Yep. Let's go to drop this request. So go back and let's go to exploit server. Let's go to here. Let's store it in there. And let's view to see if the exploit can be exploitable. It can't. So let's just choose 200 found. 200 OK, sorry. Let's view to see if exploit server can be, let's see if it can view if it can be exploit. Awesome. Let's submit the request. And it should be exploited. Solved. Awesome. It changed his email address to CryptoMux. Awesome. That works great. I'd laugh if I got an email back, but I probably would have. I don't know. Okay, that's number one done. So that obviously another way to see if it's got CSR protection. I'll do it by just by searching this whole domain. Is I like to use this method here. I like to go to right click, engagement tools, search. And I like to just search for CSRF. And I like to do it in everything, the headers, the responses and everything. In scope, dynamic update, and negative search. So negative search will do, it will make sure this is not in the request. So if I do that, the email didn't have it. These are the results it found. The email didn't have it. The change email didn't have it. Also, all this stuff didn't have it too. Also, login. So login would have been vulnerable too. Okay, that's one way. That's the way I find CSRF all the time. Another way is to go to engagement tools and analyze target parameters, and you go through each one and make sure the CSRF token is not in there. If it isn't, then it's highly likely it's vulnerable to CSRF. Okay, next part will be about doing some other advanced attacks. Okay, guys, so the next one will be about common CSRF vulnerabilities that have CSRF tokens that are exposed in a request. So this one here, I should be able to change the email to some other email address, but I think the CSRF token might need to be deleted. So let's just open up this one. This is like a good bypass for CSRFs. So the labs email change functionality is vulnerable to CSRF. It attempts to block CSRF attacks, but only applies defense to certain types of requests. And to solve it, we need to change email. So let's access the lab like so. Now it's going to have a CSRF token, but it's not going to be secure. And it's going to have, should be able to remove it and change it still. And after this, I'm going to go through some code review, and then some of like the code mitigations and maybe a couple of other labs. Let's go to account, and then I'll show you how to chain it with other ones. Let's go to account login. Let's go to type in username Carlos and the password Montoya. Okay. Now let's go to change email. But what we'll do is we'll change the email, and we have to capture a request to see actually if it's got the CSRF token. So again, we might need to copy that into the scope because it'll be different. Yep. And let's just capture this request. So we'll go cryptomux@gmail.com. Boom, update email. And as you see, it's got a CSRF protection. Now, when you first look at this, you'll go, oh, it's not vulnerable, let's skip it. But it's not always good practice to skip it, because if we just delete this, and then we repeat it, just to see what response we get back, it might be a 200 OK. It might have allowed it. Okay, I didn't like that. It said missing parameter. Okay, so obviously it needs the parameter in there, but let's delete the contents of it. Let's delete the value and see what happens. Missing parameter. Okay. What about if we look somewhere else in the request? So let's go, for an example, just wait a minute. Just trying to have a look at something. We can't just delete it. Okay. Let's see if there is another somewhere in this request that I can change it. No, this is perfect. So what we can do is, excuse me, we can spider this. Spider this and see what happens. It might have another function without a CSRF token. Email change, email change. This one, sort by length. It's got email change, and that's all my email change too. But you see that the CSRFs in different parts of the request. They're not in the right order. So let's this was a different one. We had this one here where the CSRF was last. This is different. This is actually different, this one. So let's repeat this. Let's go. And the CSRF tokens are also different. I know they're the same. So let's saying we're actually not authenticated. Let's delete this from the request. We're not authenticated. Let us which one is it? So we actually D21. Let's delete this one. So we aren't authenticated for some reason. This one is a good one. Let's see if we're actually authenticated. I might have logged us out again. Yeah, we've logged it. We're actually not authenticated. So let's go here. Let's go to reload page. We're not authenticated, so we need login again. But this one here, it says validation depends on the request method. So I think by changing the get request to something like post, we should bypass it. Because you can also bypass it by typing in different request types. So by this example, deleting the deleting the CSRF token will not work. But by changing the request type, it should work. Let's have a look at that. Let's have a look at it. Depends on the request method. So there's usually good methods like put. Put usually works. But what we'll do is we'll show you a fancy way to actually brute force that. We could just basically go repeater. You could change that to get by changing request method and go, and it will work that way. So 302, that's a good sign. Now let's delete the CSRF token, see if it works. Oh my god, look at that. We've just bypassed CSRF. We should be able to create an exploit and it will work. That is awesome. Generate CSRF exploit, proof of concept. Copy this. We also want the auto submit option. So let's regenerate. Copy this. Let's go to our exploit server, because remember we can't just do it in the normal the normal. I have to use Burp's exploit server. Now what happens when we paste in the body, our exploit in the body, and we store the exploit like so, and then we run it, we view it, it should work. Perfect, we solved it. It actually worked. We stored it and we changed the email by just changing request types. All I did was go changed request type and it works. You can just do that and it's a simple bypass. Okay, let's have a look at one more guys. Let's have a look at one more. Let's go back. I just want to get out of that. Let's go back to ports figure. Examples. I can type. And then we will oh, here we go, it's right there. Okay. Okay. Ports figure, let's go back. And let's have a look at a different one. CSRF token depends on token being presented. This one's going to be a nice one. So this one here is going to be, I just know, it says validation when it depends on the CSRF token being present. So this is the one when we delete the CSRF token, it will allow us to bypass CSRF protection. Let's have a look at this one. Copy that, and we'll paste that in here. Delete that. This one should be a very simple one. We will delete this in scope item, and we'll go here, and we'll just go log in again as Carlos and Mentos. Carlos and Montana. Carlos and Montana. The whole point of this is to be authenticated. If the user is authenticated, that's when you can execute these actions on their browser. Let's change email. And in the request, I can just visualize there being an CSRF token in the response body. And then what will happen is we just delete it, we just check the response. cryptomux@gmail.com. Okay, so first of all, we need to, I'm just going to make it easy and not turn on only intercept on in-scope items. Just to be simple. Just to be a little bit simple. Make things easier. This video is so good so far. We're doing really well, guys. It takes a lot of time to practice. I hope I'm making it as simple as possible. Soon you'll be CSRF champions. Okay, there's a CSRF token in here. Let's go to repeater and let's check it out. Let's check the response response status. So it's a 302 redirect. This is now we know that it's actually been bypassed. If we get a 302, we're good. Now this token, I just want to show you, by the way, we can't just simply decode it because of the encryption algorithms it's got. It would have a really strong algorithm and a really strong cipher, so we can't just decode it. There's no decoding options. Just to show you that. Now, if we just send this to repeater and delete the CSRF token, let's just put equals there, just so it has a parameter there. Okay, missing parameter, let's delete it all together. Awesome. So if we have it, so it has the parameter but not the value, it doesn't work. If we delete it all together, kaboom, magic begins. We actually have bypassed the CSRF token by just checking the response. Now let's generate a proof of concept. Copy this, turn off or drop the request. It's going to ask us to resend it. Let's go back. Let's go to exploit server. And then let's just paste in the exploit in our body. And then store it. And let's view the exploit. Obviously, we forgot to select the auto submit option. Auto submit option, so we can just submit it ourselves, and it should work successfully. Let's try that one more time. Let's try it again. Just wait. Try that one more time, but with the auto submit option. Repeater. Generate our proof of concept, and then we'll just choose auto submit, regenerate. Boom, boom. Let's go to our exploit server. This time, hopefully, it works because we forgot to select auto submit. Restore that, and hopefully, it works. Let's have a look at the access log. I didn't like it for some reason. Okay, let's go back. Let's just do this again. Okay, let's go back. Let's change email. Maybe there's been something I just missed. Let's have a look. Just try and do it methodically. Just do that email there, stuff it. Just do a different one. Delete that. Generate a proof of concept. Make sure it auto initializes. We regenerate it. We copy this. We drop that. And then we go to our exploit server. And then we paste it in. And then we store. And it should work, hopefully. Boom, done. Awesome. It's just a bit of confusion what was going on. Awesome. So we've figured out a couple of bypasses there by just changing request type to get or post, or even put can do it. And we've also done it when the validation depends on the token being presented. Let's have a look at one more. We'll go through the code review, and we'll also go through the mitigations and also some of the real life examples we can use to actually get more impact. This one is a token is tied to a non-session cookie. So you can see the CSRF is in the cookie too. That's another, we can bypass that. So when that's tied to the non-session cookie, it means that we can just delete the CSRF key and we should probably get access to it. And token is simply duplicating a cookie. So we can remove the CSRF from the cookie and it should work. Validations on referrer depends on the header being present. So just, how about we don't do one more? How about you just practice these yourself, get used to them, just play around. If you have trouble, just go, view the solution and you'll learn from it. Don't be afraid to view the solution. That's how you'll learn. That is how you'll learn to become a good hacker. Okay, so let's have a look at some really, really bad cases of CSRF. And one of them is called CSRF account takeover. Now this is when you can actually take over account with CSRF. And there's also a medium write-up about it. And this is basically by just changing, if there's no CSRF protection in the email, change email form and change password form. You can then change it to whatever you want and take over their account. Here's an example of what it will look like. So let's log it into the victim's account. And what he's going to do is he's going to change the email address and password of that account. The party. Keep on watching. Sorry about that. I just sort of went back a bit. I was just verifying if I was correct. But what it will do is it will change the email address to the attacker's email address, all the account information to the attacker, and then the attacker will gain access to his account. It's going to swap these over. And as you can see, there's no CSR protection at all. It gets the victim to open up the malicious file, and that should all change. It's not authenticated, and you'll find that it will all be changed. All his account information should be changed, leading to full control of his account, full account takeover. As you can see there, he taken over his account just by changing their account information because there's no CSR protection. That is one very bad way. That's a very bad case of a CSRF. Now, excuse me, if you don't want to, if you're doing login, log out CSRFs, they're going to deliberately be vulnerable because they are very low impact. You don't even need to worry about those. Another one is XSS change with CSRF, and I found one of these lately, and I'm going to show you my proof of concept of it. How to exploit XSS with CSRF. Now, I had a report where I sent them a report with XSS. There was a sign-in form or sign-up form that was vulnerable to XSS, but they thought it was like because you had to hover over the X to execute the pop-up payload, to be able to trigger the XSS. They said this is basically self-XSS. So I reported to them. I found out there was no CSRF protection. So I then generated a CSRF proof of concept in Burp, like we've been doing before, with my XSS payload. So all the person needed to do is open up the file, hover over the X, and they'll be exploited. So that was not basically self-XSS. And this is another way to do it. So obviously, here we go, the get user configuration. Must be reflected back in the response, and then with some basic XML HTTP requests, so like a XHR request. So they open up the file, and it will just, or actually they can just open up the file and they can trigger the XSS, something like that. It's pretty cool, and this could be used to steal cookies and stuff like that. You watch my previous video about cross-site scripting. I go over some pretty advanced stuff in there, and I will be going over more advanced topics very soon, like ways to increase impact through JS keyloggers, XSS shells, and session fixation, and more. So that's it. That's an account takeover. So all that is required. For an example, I will show you. Just on a website, I'm not going to show one that's vulnerable because I don't know when it's vulnerable. But just for example, we'll look at how about mail.ru. So what we'll do is we'll put mail.ru in scope. This is like what during a bug bounty test. We'll put mail.ru in the request. I'd use advanced scope control. You would go add and put mail.ru, and you just go okay. And you might make sure the only intercept like client requests only that in scope. Choose in scope items, perfect. And these are all your mail.ru domains that's found. So you want a spider, and you want to make sure you search for CSRF that isn't included in the request or response. There'll be a lot still, but we're looking for the ones like login or account details. Update, so this one has it in the not in the update field. This could actually be vulnerable. If it's an update email, this could be vulnerable. You just don't know. It's something you actually should look at. Don't know what that update is. But what if you would look at something like you log into the account, for example, not going to bother about login or log out CSRF, doesn't work. It's not really big impact. Let's do here, and what we'll do is we'll go to the account details, and I'll show you ways to actually do account takeover. It's probably not going to be vulnerable to. It's probably going to have CSRF protection. We can try some bypass and see if it works. If it does, then we've got a hit, then we have to report it. Then I'll probably have to wait to release the video until it's resolved. But I doubt that. Let's just go to the login account. Get out of these. All these. This is the process you would go through, and there's also automated tools you can use. So there's also you just type in CSRF scanner for Burp or for on GitHub, and there are tools that you can use to scan for websites that have CSRF protection. There's Bolt. There's one called Bolt. Even Portspeaker, even Burp has one too. So Bolt looks like a good one. Also crawls and checks to see if there's any CSRF protection. That's a good tool. Automation is good for CSRF in some cases. And there's also a tool called in Burp. There's one called it's really popular. It's called CSRF Scanner. That's a good one. Check to see if there's any CSRF vulnerabilities. So we're not going to worry about that. We're going to do it ourselves by just searching for it in the scanner. And you still need to check yourself. So there's obviously no CSRF protection. This one, good. But and by the way, I found quite a lot of SSRF on mail.ru. So that's pretty good. That's a good website to test for SSRF. I'm actually participating in one at the moment. Okay, so We did that. Let's go to our settings. So we go into our account settings, and this is what you would usually do. So just check to see what that is. I think it's in the, what's that? Inbox, user info. So down there, user info, right down there. So user info. So if we go there, obviously this is in Russian, so I'm not going to be able to understand it. But let's go to our user info. And user info, by the way, is good to check for cross-origin resource sharing vulnerabilities. But we'll just go to user info. Another thing we can do to filter out instead of going to search, this one doesn't have any CSR protection, this one here, but obviously it's the JS extension. We're not going to worry about that. We can also go negative and also do it in the filter search here. That's another way of doing it. And that will also filter them out too. It's two ways. Now, let's say we want to change our, just say our name, just want to change our name. So we'll just go hacker. This probably won't be vulnerable. We'll just have a look just to see. If it is, it's definitely low impact because we're just changing the name. That's nothing is serious. So we'll save that. And forward that off. Okay, see there is okay, there's no CSRF protection on the change name. That this is a vulnerability, but it's actually not a very bad one because we're just changing the name. It says form token. That obviously has CSRF protection, I think. So if we change it to, if we change the request type and see if we go, and what we'll do, it's got to change the name, but we want to delete the form token and see if that will bypass that. Okay, it worked. So now let's just choose CSRF. Let's just so CSRF. Let's just generate a proof of concept. We'll do it on AutoInit. Generate. We'll test in browser. Copy, and we'll just like drop this request here so we don't actually submit it. So it doesn't change my name. Let's reload the page. We turned off the proxy just because we don't want to actually submit it, otherwise it will change my name. This is a very shit example, but this is probably going to work, but this is actually a very, very low vulnerability. We want like account takeovers and stuff like that. Okay, so we need to log in again because it might have logged us out for some odd reason. Let's just go back maybe. There we go, awesome. Okay, hacker. It did it. Let's just go to Zoid. Let's just save it as Zoid again. Awesome. Let's go to, it's asking us to log in. We'll log into it. I can imagine there being a CSRF vulnerability to log into to change the email. I just got a feeling. Because when it redirected me to login page, there might be an email address where do you want to redirect it, things like that. I'm not sure. There could be there's CSRF in every website. There's CSRF vulnerabilities everywhere. Let's go back, and hopefully it doesn't say hacker because I dropped that request. I'm waiting to execute the script in the browser. I want to actually test this in browser and turn off the proxy. Awesome, it's turned off. We'll just have a look. We've actually got a lot of pages that are vulnerable to CSRF. But they're all like ended in JS. That's not going to do much for us. Mail.ru. The main domain has does contain no CSRF token, but there's nothing we can really do with that one. Okay, so the name is still, let's have a look. The name is still Zoidex. So let's go to the user info, and let's paste this in the request. So it will change my name to hacker. Let's have a look first. Still Zoid. If we run this request, submit it, it's hopefully going to change my name. Okay. It did not work. Or did it? Obviously there is actually protections involved, so it didn't work. Someone's already tested this and figured it out. But another sort of one would be to upload an image and check for CSRF, because if you're allowed to upload images through other websites through SSRF vulnerabilities, that's very bad, because you can upload like photos that have like pictures of nudity or like mature content. So that's another one. Photo uploads are still good. Deleted accounts obviously are, and there's various other CSRF that we can do. That's just the process you would go through, and you'll check to see, these obviously all don't have CSRF tokens, because I've filtered it out so it hasn't got that. Negative search. What you do is you then go here and you would right click and go find analyze target, and you'll check for like login account details, like account ones. For example, you might look for count of email. That has no CSR protection. There's no content. Default email. No content. You just check through each URL, and you find things like change email, change password, upload profile, things like that. So password, parent. No, that's probably not going to be vulnerable. Password. Nope. Probably not there. What's that? Update. Auth. So yeah, I would recommend looking at mail.ru. That's probably a lot involved. Share. Believe it or not, I found SSRF on share.url_URL, but except that had SSRF protection, so it was not. It was just informative. Yeah, just keep on looking. URL. Nice one. That's pretty interesting. If you want to find your first SSRF, try and check out that URL parameter there. I'm giving you that option. Check out the URL parameter for what we can do is we can go to a repeater, or we can go to burp, collaborator, and just copy that in there. If we get a hit back, we'll then use ngrok to see what the IP address we get back, and we found SSRF. Got a response back, all right? It's poll. All right, nothing there, so that's not vulnerable to SSRF. Damn. But that's basically the procedure I go through. Okay, so now let's look at some mitigation. So we've talked about some of the attacks. We've talked about how to create more impact through like cross-site scripting and account takeovers. And by the way, the cross-site scripting one was pretty simple. All I needed to do is create a XSS, a CSRF with the XSS in there. So I'll show you my exploit I've got for my page I'm actually currently hacking, which is app.scythe. You won't be able to report this because you'll get a duplicate and you'll lose lots of points. So obviously the sign up page was a post request. It asked for the name and email, and the email was vulnerable to a XSS that if you injected a mouse over X, it will then bypass the XSS protection, but you had to type that in to actually get it to trigger the exploit. So they wanted one that I could just do one off. So I did this, create a CSRF proof of concept, and made a submit. And when I open this, I'll show you what happens. This is actually one I found. And a mate of mine's like, yeah, add CSRF. It's got no protection. I'm like, cool, I'll chain it with CSRF. So I don't even have to, okay, I do have to submit it. I've got the auto submit somewhere else, I think. So I submit that. Actually, I'll do it in Chrome. Chrome I'll do it in. I'll do it in Chrome. It automatically submits. It's a sign up form. It's got this X, and if I click X, it injects it gets my cookie. This can be changed with like JavaScript keyloggers. It can be changed with XSS shells, but I tried all that and it didn't work. Okay, let's have a look at the CSRF protection. So the mitigations. Let's have a look. Pretty sure I got a page here. Let's have a look. CSRF mitigations. Here we go. The prevention cheat sheet. Mitigations methods. Now, all that is involved, it's pretty simple. All you need to make sure of is that you got a CSRF protection, CSRF token. Actually, there was a really good mitigation here somewhere. Let's have a look. These are all the mitigations. So, where is it? There's a really good one somewhere. Might have been that. Really good one somewhere. Here it is. That wasn't it. Maybe that was. Yeah, this is the one. So this is the token-based mitigation. So when we saw before we had tokens to protect against CSRF. They're just long strings of numbers. And it says This defense is one of the most popular and recommended methods to mitigate CSRF. You know, when you have the big long token in the request or the header or the response, that's basically the protection. It's very common. It can be achieved either with state synchronizer token patterns. So that's a type of algorithm that will basically generate a new one each time, or a stateless encrypted hash-based token pattern. See in section 4.3. Let's go to that. 4.3. Let's keep on reading here. There might be a link to it. Let's have a look. Where is it? Here it is. Encryption-based token pattern. So an encrypted token pattern leverages an encryption rather than a compromised method of token validation. It is more suitable for applications that do not want to maintain any state at server side. Servers generate tokens comprised of the user session ID. Sorry, I meant in rather than comparison method token validation. So I'm going to have this resource in the Patreon page. I'm very bad at reading, so my English is absolutely shit, so I can't read. I'm not going to read all this. But all you need to know is it needs to have a big value, a CSRF token, and the best place to have it tells you up here. The best way to do it. It's actually I'll try and find it for you. I think I saw it here somewhere. It tells you the best place to have it. Let's just search for JavaScript. So yeah, okay, so it says here synchronizer token pattern. The CSRF token can be added through hidden fields, headers, and can be used with forms. An AJAX clause makes sure that the token is not leaked in a server log. So we're going to make sure when you actually got server logs that it's not in there. And in the URL, you want to make sure the CSRF token is not in the URL, otherwise that can be deleted and bypassed. The server must reject a request action if the CSRF token fails validation. So what you would have is some sort of CSRF token validation. So it might check to see if the tokens are a match. The ones you give it through the request are a match to the actual one on the server side or the one that's presented. And if it's not, it will cause a crash and it won't work. It will just say invalid token or something like that. Inserting the CSRF token in the HTTP request header via JavaScript is considered most secure than adding the token in a hidden field form parameter. So having it in the header field in JavaScript is a lot better. Request header via JavaScript is a lot better. So you have it in the request header and you program it via JavaScript. So client-side code. In this situation, even the CSRF token is weak, predictable, or leaked, but still an attacker cannot forge the post request directly by setting a custom request header through XML HTTP request. So it can still be vulnerable, but an attacker is going to have a bad time trying to exploit it. So these are all really useful. It's good to maybe have a read through this. Like here is an example of a synchronized token pattern. So web applications formulates a request that application should include a hidden parameter with common names such as CSRF token as a header parameter value by AJAX clause. So this one here is a hidden. So this one has a form action transfer do, and it's a post method. So this is going to transfer some sort of funds to another account. But in the hidden input field of name CSRF token, it has this huge string of values, and this is what stops CSRF protection. Okay, so obviously CSRF protections or CSRF in any request anywhere will have this common name CSRF. That's why when we went to burp, I searched for I did like if anywhere in the request does not contain CSRF with this invert match, then it's got no CSRF protection because CSRF is a common name. Whereabouts was I? I'll get that in a minute. So yeah, that's just good to read through that. There's also CSRF guard, also some tools to help with synchronizing and help with CSRF protection. That's usually useful to have a look at. An encryption-based token is really good. There's all different methods of CSRF. Just some websites use it in a different way, or they make it too complicated that it stuffs up the whole website and CSRF mechanisms. Another one is to look at the code review. So release code review. And this is a code review of some of the vulnerable codes throughout the whole year or so. So we'll go down. we'll have a look at some code and we'll analyze it and we'll see which ones. We'll see if we can spot out the vulnerable code. I think it must have code review. Is that just like a stats or something? No, there's actually vulnerable code. Okay, so let's look at an example. Let's have a look at PHP SQL injection. Obviously, we haven't covered this yet, but I'm going to explain the code. So PHP, that's what happens at the very first of the line. It's a variable pass with a $sign. Usually variables in PHP start with a $sign, and it's set in the pass variable. It's assigning the get parameter pass to the pass variable. So in the URL, there should be a pass parameter, and it's connecting to the database. It's selecting what database we want to use, and it's selecting all the users from the password, and it will print a result in the SQL. It will print out the result. Oh, sorry, it's selecting all the cards from the users where password equals password. So it will say there's a card, like, so there could be like it might be like Pokemon cards or Digimon cards. I'm a bit of a nerd. It will select all those cards from all the users. But as you can see, this password has been concatenated to the string. So there is no sanitization, there is no binding variables, there is no mitigations, there's no anything. There's no bind variables, mitigations, there's no what are they called? There's no like mitigations involved basically. So parameterized queries and bind variables, none of that. No escaping, there's none of that. So this is a vulnerable code, because all we can do in this is in the password field we can select a quote like that, a quote. So all we need to do is inject a quote, and a quote like that, and it will cause the query to crash, and we'll get access. We can then inject other nefarious SQL statements to access the database and even get remote code execution just through that quote. Or you can URL encode that quote. There's all different sorts of way of testing. You can URL encode that quote, which you'll be able to see in here. You just go here and go encode to URL. You can use a %27, or you can use a HTML, or you can use different variations of that quote to see if you can bypass some of the filtering and get an error. This book will also be in a description too, to have a read of some code. So that's vulnerable. That part's vulnerable there. Let's have a look at another one. And obviously to protect it, you need certain functions like add slashes, but I think, yeah, they're vulnerable these days too. I think add slashes are. I'm not sure. There is a lot of functions that are still vulnerable. Now that's another SQL vulnerability. Yeah, it's just basically good to read all this and go, oh, think where it's vulnerable. This will help you understand code-related issues and figure out how to find vulnerabilities in code. This one's the OS command injection one. So OS command injection is when you can, something like you can go, so there was a parameter. Actually, I can give an example one actually. So I go sudo cd var, I'll give you an example one, cd var www.html, and this would be called sudo nano cmd.php, or ping.php. And I'll give you an example of a code execution vulnerability and how to mitigate it. So you might have a PHP code like, say, you might have echo, it's going to echo out some HTML saying something like shit, I'm really bad at typing. Ping server. Actually, what I could do is I could just go, I'd make a parameter, it might be easier. So I go, I'll just go IP equals, and IP would be a common parameter, and we want to use a get, and want to use a thing called like server. The server is also another example of a parameter that could be vulnerable to vulnerable to command injection. Then we go to system IP. So it's going to first of all ping 127.0.0.1, and it's going to concatenate IP. So it's also going to do that as well. So actually ping the IP, sorry. So whatever IP we give it in this parameter, it's going to ping. So we run the server. and we just want to go to our local server 800, and we'll just go to ping.php, and we'll give it the server 127.0.0.1. Oops, my bad. And it should, actually, for instance, I need to actually ping it for 3 times, otherwise it will go in a loop and it will crash. So ping, and we'll do count 5. Like that, perfect. Now what we'll do is we'll run this. And you'll see the results of the ping. It will ping out results. We actually need echo, because I did it in the background. So we want to echo out the results. Like so. We echo out results. It's going to ping it. Just wait. It did not work. Echo system ping 5. We ping out. We need to put a space there. That's why. So do that. Ping out 127.0.1. Should hopefully print out the results. It will do. Yep, there you go. It worked. Awesome. So it printed out the ping. So this could be some server that it passes in a host name or an IP address to see if it's up and alive and it's pinging. But what they don't realize is they haven't actually had mitigations in place. So we could immediately check to see if it's vulnerable to command injection. So we can comma or a and or any sort of pipe and pipe in ls. When we do that, it's going to execute the ping command and it's going to go or print out the next command, which is ls, and that's what we've got in our directory. We can also go ping 127.0.0.1 and also after who am I, and it will say root or zoid. So that's vulnerable to command injection. Now that's because where are we? That's because this is a JavaScript example, a Java example, but we did a PHP example. That's because what we're doing is we're going, okay, we're going to ping. If you look at the code, I'll just split this up in half, so I'll go to 2 mux. What we're doing in the code is we just split this in half. Sorry, I made a mistake there. Wait, what's going on there? Get out. Go, I think it's that. Try and think of how to nuts that. How do I split in half? Just wait, this is split. There you go. No, that's it. Look at that. Just wait, I fucked up. Yeah, get out. I'll just get out. Just wait. I open up 2 windows stuff. I can't be bothered figuring out how to split it. So if you look at on this side, I'll show you how it's vulnerable. Do that side. I'm going to open up a new window and be on that side. So if you look at the code of the OS command injection vulnerability, ping, you can see that we're passing in a server IP through a GET request, and it's pinging with 5 requests. That's gone ping -c5, and then at the end it's appending the IP that we put in a parameter. But there's no checking to see if it's a different IP. There's no filtering. There's no mitigation. You can just pass in absolutely anything in the server IP. So if say we passed in a pipe and ls, we can't just type in ls because that will cause an error. But we pipe it with any sort of pipe. It could be end ls, and it will do both commands at once. Or we could do or ls, and it will be doing both commands at once. And what that's doing is that's going, whatever's in the IP parameter, it's doing or, and we're passing ls as the IP parameter. It's doing both commands. If you know what I mean, it's pretty simple to understand. But in order to mitigate this, it's either input validation to see if we're only allowed the trusted commands. So that's sort of like a blacklist would be better, not a whitelist. To black out, no, actually, we like whitelist only commands we want to type in. So whitelisting is probably better. Data validation to make sure it actually is what we want, what the data we want it to be. Canonicalization, which is really good to make sure that we're in the directory you're supposed to be in, and we're not just in any other directory. And there's like and also user supplied input checking. So all these mitigations face system example code. So I'll give you this also to check for code reviews and look at code and see where it's vulnerable. It's very easy to spot the vulnerabilities because they're usually just things that haven't been sanitized or haven't got any mitigations in place. It's pretty simple. Don't think a CSRF will be in this one though. Let's have a look. CSRF isn't in this one. That sucks because I could show you a CSRF example. I know there might be. Let's have a look. Is that CSRF there? Here you go. Here's the CSRF examples. So, okay, here's a CSRF example of vulnerable code. An attacker makes the victim perform actions that they didn't intend to, such as purchase an item. You can see that the HTTP post has a ticket vendor to purchase a number of tickets, but there's no CSRF token. So it gives us back a thank you. It proceeds and it likes the request. And it tells you how to fix it. This is perfect to look at. Another one is like, you might do a transfer. Actually, that was just an example of mitigation. But yeah, all those are in, like, CSRF is very common, very bad, and it's good to look for some examples. Now, if you're new to this Patreon page, I've also got other videos out too. If you just go to Patreon/CryptoMux, patreon.com/CryptoMux. I've also got videos for XSS as well. That's this old one. Advanced XSS techniques and recon as well. So I'm going to be releasing this video hopefully tomorrow or maybe tonight. I'm just going to edit it. And for those first 10 people that actually become a Patreon, will get free stickers. So they'll get 10 stickers each. They're really nice stickers. You can put them on your laptop or just put them on your window, wherever. The VIP Patreon basically has access to all my private mentoring video tools and private posts, and the premium is only access to my tools and private posts, and this is the only official Patreon which you can uncover my private posts. Yeah, so I hope you enjoyed this video on CSRF. I went through quite a lot. I went through some of the mitigations, some of the tools, some of the ways to chain it, and other various stuff as well. It's all about practicing, all about looking for it. Later on, if I learn more techniques about CSRF, I might release another video. But that's all I know so far.